We have seen that the tortoise was slow, but he was steady. So this is the time taken by tortoise, and this is the displacement of tortoise. So let us see what was his velocity at different points in time. After 10 seconds, displacement was 4 meters. Velocity is displacement by time. So it is 4 meters by 10 seconds, that is 0.4 meters per second. After 20 seconds, displacement of tortoise was 8 meters. So velocity is displacement by time, that is 8 by 20, which gives us 0.4 meters per second. So in this way, we calculate the velocity for each time interval. So this is the time versus velocity table for tortoise, time taken and the corresponding velocities. Now we plot the velocity time graph for tortoise. We plot time on the horizontal axis or x-axis and velocity on the vertical axis or y-axis. We mark the points, that is, for time equal to 10 seconds, velocity was 0.4. So we mark a point corresponding to 10 seconds and 0.4 meters per second. At time equal to 20 seconds, velocity was 0.4 meters per second. So we mark a point corresponding to 20 seconds and 0.4 meters per second. This way, we mark all the points and then we join them to get the velocity time graph for tortoise. So this is what the velocity time graph for tortoise looks like. Now we see that velocity time graph for tortoise is a straight line parallel to the time axis. What does it mean? It means that even as the time increases, velocity remains unchanged. At time equal to 20 seconds, velocity is 0.4 meters per second. At time equal to 40 seconds, velocity is 0.4 meters per second. So velocity is constant over time, and we can say that the tortoise is moving with uniform velocity. So in general, if a velocity time graph is parallel to the time axis, we can infer that the body is moving with uniform velocity. Now we know that velocity is equal to displacement by time. So displacement will be equal to velocity into time. Now from a velocity time graph, we can calculate displacement, because if we know velocity, if we know time taken, multiplying them, we can get displacement. How do we do it? Let's see. Say I want to calculate the displacement of tortoise at 70 seconds. So at t equal to 70 seconds, this is 70 seconds. It lies between 60 and 80. So this is 70 seconds. At t equal to 70 seconds, what is the velocity? We find the point on the velocity time graph corresponding to 70 seconds. So this is the point on the velocity time graph corresponding to 70 seconds. And this point represents a velocity of 0.4 meters per second. So corresponding to this point, velocity on the y-axis is 0.4. So at t equal to 70 seconds, velocity of tortoise is 0.4 meters per second. Time taken is 70 seconds, indicated by this distance. So what is the displacement? Magnitude of displacement is given by velocity into time. And we see that velocity here is 0.4 meters per second. And time taken is 70 seconds. So we get displacement as 0.4 into 70, that is 28. And we get the unit as meters. So at t equal to 70 seconds, the displacement of tortoise was 28 meters. Now we have seen that magnitude of displacement is equal to velocity into time. This distance, this is the velocity, and this distance, this is the time taken. But what is this distance actually? If we consider this rectangle, this shaded region as a rectangle, then this distance, that is the velocity, can be considered as the length of the rectangle. So velocity can be considered as the length of the rectangle. And if we consider this distance, that is time taken, it is actually the breadth of this rectangle. So time is the breadth of this rectangle. So we can also say that displacement is equal to velocity into time. For this case, it is equal to length into breadth, and length into breadth gives us the area of the rectangle. So this is equal to area under the velocity time graph. So in general, we can say that magnitude of displacement is equal to area under the velocity time graph. Now that area could be the area of a rectangle, it could be the area of a triangle, a trapezium, or any shape, but it has to be the area under the velocity time graph from the time to the time for which we want to calculate the displacement. Now solve this question. Find the displacement of the tortoise while the rabbit was sleeping from t equal to 30 seconds to t equal to 70 seconds. Now we have to calculate the displacement of the tortoise. We know that magnitude of displacement is equal to area under the velocity time graph. We have to calculate displacement from 30 seconds to 70 seconds. Now where does 30 seconds lie? Between 20 and 40. Where does 70 seconds lie? Between 60 and 80. So we join this and this. So area under the velocity time graph from 30 seconds to 70 seconds will give us the magnitude of displacement. What is that area? That area will be equal to the area of rectangle ABCD. Because we want to calculate displacement from 30 to 70. So we consider only this region inside this rectangle. So the area of this rectangle will give us the magnitude of displacement. What is the area of a rectangle? It is equal to length into breadth. So area of rectangle ABCD will be equal to CD into AD. CD into AD. What is the length of CD? CD is 70 minus 30, that is 40 seconds. What is AD? AD is this distance. This distance is equal to 0.4 meters per second. So 40 into 0.4 gives us 16 seconds into meters per second gives us meters. So displacement of the tortoise while the rabbit was asleep from 30 seconds to 70 seconds was 16 meters. Now how do we find the displacement in this type of graph? Let's see. Now we need to calculate displacement from 10 seconds to 20 seconds. We know that magnitude of displacement is equal to area under velocity time graph. Here we want to find the displacement from 10 seconds to 20 seconds. So we need to find the area under the velocity time graph from 10 seconds to 20 seconds. This area. So this is nothing but the area of region ABCD. So area under velocity time graph from 10 seconds to 20 seconds, that is equal to area of region ABCD. Now we can divide this region into two parts, this triangle and this rectangle. So area of region ABCD is the sum of area of this triangle ABE and the sum of area of this rectangle AECD. That is what we have here. Area of region ABCD is equal to area of triangle ABE and area of rectangle AECD. What is the area of triangle ABE? Area of a triangle is equal to half into base into altitude. Base is AE and altitude is BE. Area of rectangle AECD will be EC into DC. So this is what we have here. Now let's put the values. What is AE? AE is this distance, that is from 10 to 20. So 20 minus 10 gives us 10. What is BE? BE is this distance. It is 0.6 minus 0.4, that is 0.2 meters per second. We only write the magnitude. What is EC? EC is this distance, that is from 0.4 to 0.2. It gives us 0.2. And DC gives us this distance, which is from 10 to 20, so it is 10. So we get this as 10 into 0.2 is 2. 2 divided by 2, 1. Plus 0.2 into 10 gives 2. That is 3 meters. So the displacement in this time is 3 meters.